structural steel shapes, we touched on a few of these when we were looking at our dead load portion in Monday's class, but just as a refresher, most of the shapes that we're going to look at are this upper left one, so the W shape, wide flange, or an I-beam. The WT was simply the I shape cut vertically, so we end up with a WT top or bottom. And these are used quite frequently in connection design as well as truss design for upper or lower lateral bracing. They're easy to work with because they have that 90 degree. It's easy to put some bolts in it and attach it to a gusset plate. Now the S shapes, these aren't as frequently seen or used in industry. The one application that comes to mind is probably for machinery or mobile cranes. Usually the boom for a mobile crane is an extruded S shape. One fits inside the other. And it's a little hard to see from the figures, but you can see that the tips of the flanges are not as much at a 90 degree. They're rolled down to almost a tip at the end. And so that lends itself to extruded shapes and just kind of rollers on the inside, similar to what you'd find in a crane section. And the ST, similar to the WT. We also looked at channels. Angles are new. You can have equal or unequal legs of different thicknesses. I say the same thickness, but different leg lengths. The HSS sections, and were the tubes. I looked at those. Circular, square, or rectangle. And we refer to the main ones as rolled shapes. Essentially, they start with a larger piece of steel, heat it up, and force it through an ever smaller series of rollers, so they get the shapes that are shown here. Now, there is a limit to this. If you go to the steel manual and you look up the structural shapes, I believe a 44-inch is the deepest that they can roll. So you say, well, what if I need an I shape that's bigger than that, or deeper? That does happen, and we refer to these as plate girders. So instead of making the shape as one, starting from one piece of steel, we essentially just make it from individual pieces, and then we weld them together in and out of the page. So you'll see this quite often for some of the larger river crossings if they still use these shapes. Also in some of the older railroad trestles, they're usually built up sections where you might have an angle section connecting the web and the flange and pieces of steel at various lengths along that span. So in this case, we'd have a plate for the top and bottom flange. They could be separate thicknesses and widths. And obviously, we'd weld it, full penetration welds between the two. So that's what's known as a plate girder, and that can run into some issues, which we'll see in the next couple slides, with respect to the thickness of each of these individual members. It can lead us into some trouble.